All right, so in the last lesson, we learned about how to identify where two functions are equal to each other. The idea behind where does f of x equal g of x. And understanding this is saying that the y coordinates of these two functions are already equal to each other. Where does that happen would be at the x coordinate of any of those points. And that those points are represented by points of intersection. So in this case, this point, both y values, both function values would be 2. And where that happens is at an x coordinate of 1. And this other point of intersection, again, both y values are positive 2. And where that happens is at the x coordinate of positive 3. So the conclusion to where f of x and g of x are equal to each other would be at x equals 1 and x equals 3. All right, so we're applying this now today to the idea of solving quadratic equations using the graphs of two functions. And so such a quadratic equation such as this one right here, we can turn into two functions by adding 2, undoing the subtraction and adding 2 to both sides. And that's what this is doing right here in step 1. So taking our quadratic equation here, which is the same as this one up here, and adding 2 to both sides, it creates 2 times x minus 4 quantity squared equals 2. And then what we do is we take the left side of this equation and turn it into one of our two functions, such as f of x equals now that 2 times x minus 4 quantity squared. And our second function is created using what the expression that's on the other side of the equation, of the equal sign, which is 2. So g of x equals 2. And now to solve this particular equation, remember we're solving this equation here, that actually now means where f of x is equal to g of x. So graphing each of those, so f of x equals 2 times x minus 4 quantity squared would be a quadratic because of the x squared, which means it graphs as a parabola. And its vertex would be h comma k. And its h value is positive 4, and its k value is 0. So it has a vertex here at 4, 0. And then a is equal to 2, which tells us we have a vertical stretch by a factor of 2. So it goes over 1 up 2 to the left and the right. And then g of x equaling 2, that we have to realize is a linear function, but specifically it's a horizontal line called a constant function. And it means that y is equal to 2. So it represents all of the points that have a y value of 2. And that would be the horizontal line then that goes through 2 on the y axis. And then to answer the question of what are the solutions to this equation, we use what we learned yesterday, which is finding those points of intersection and where the two functions are equal to each other, which are at positive 3 and positive 5, are x values of. Therefore, the solutions to the equation we started with are x equals 3 and x equals 5. So they are the solutions to this equation, as well as where the two functions are equal to each other. So that's the idea, that's the concept that we are applying today. All right, so let's look at a couple of examples. So this right here is the steps that I was just going over written out. So create two functions is our first step, f of x and g of x, using the left and right sides of the equation. And we will often have to move something using our algebra from one side to the other to create a non-zero on both sides. We'll graph those functions, and based on the types of problems we're doing today, one will be quadratic and the other will be linear. And then we will determine where f of x equals g of x at those x coordinates of the points of intersection, and then make the conclusion that those are actually also the solutions to the equation that we were actually solving to begin with. All right, so let's look at this problem. So we are to solve the quadratic equation, which is this right here. And the strategy or method we are to use is using the graphs of two functions, which is the steps that I have just been talking about. So we must write and graph the two functions to use this method, and then we must conclude our problem by making sure we state the solutions to the equation, which is this right here. This is our equation. All right, so let's call this, so write and graph the two functions. We'll call part A the right. And so what we would do is, taking our equation, we need non-zero values on both the left and the right. So I'm going to add 4 to both sides here. And this is going to create x minus 5 quantity squared equals 4. And so the left side is going to become one of my functions. Doesn't really matter which one, but I'm going to let that be my first function here, f of x. So f of x is equal to x minus 5 quantity squared. And I need to realize that when I graph that, it's going to graph as a parabola because it is quadratic, that power of 2 on the x. And then my second function I will create using what's over here on the right side. So my g of x will be equal to 4. And this is what we call a constant function, which is a special kind of linear function that is a horizontal line. And all right, so having that, we now begin part 2, or step B here we'll call it, which is to graph each of those functions. It does not matter which one you graph first. I'm going to graph my parabola. So to graph my parabola, I need to know my vertex. And again, vertex of a parabola in its vertex form is always h comma k. And so h is the opposite of this minus 5, which would be positive 5. K is the value added or subtracted after the quantity squared, which would be 0 in this case, since we see nothing. So 5 comma 0 is our vertex. Then we need to know, okay, do we have any reflections across the x-axis, any stretches, compressions in the vertical direction? And that has to do with our value of a, which we have to here recognize would be equal to 1. So that means there is no stretch, no reflection, no compression. It's just the basic shape of the parent function f of x equals x squared. So remember your key points for f of x equals x squared. Vertex at 0, 0. And then we have 1, 1 and negative 1, 1. 2, 4, negative 2, 4, 3, 9, and negative 3, 9. So that means from here that we're going to go right 1 and up 1, and left 1 and up 1. So this would be our 1, 1 and our negative 1, 1. And then our 2, 4 would be 7, comma 4, and 3, comma 4. And our 3, 9 and negative 3, 9 would now be at 8, comma 9, and 2, comma 9. And this is now our function that we have called f of x. So I'm going to label that. All right, and then I'm going to move on to graphing g of x. And g of x, again, g of x equals 4. G of x, remember, represents all of your y values. So this is saying all of your y values are equal to 4, no matter what x is. Y is 4. And that means that it contains all of the points that have a y coordinate, this is our y-axis, of course, of 4. So it has the point 0, 4, 1, 4, 2, 4, all of those points that have a y coordinate of 4, which creates a line that is horizontal through all those points with a y value of 4. So this is our g of x function. So now we have a graph. Now we have to understand how we're interpreting this graph is by determining where f of x equals g of x. And so f of x would equal g of x at these 2 points of intersection. That's saying that the y values are both 4 in both of these cases actually, but where that happens will be at an x value of 3 and an x value of 7. And so what we have to understand then is that means that these values of 3 and 7 are the solutions to this equation. So the solutions, our conclusion here, to the equation x minus 5 quantity squared minus 4 equals 0 are x equals 3 and x equals 7. Now, if you're not quite sure why still that is, another way to look at this is with the idea that these x's, when plugged into this equation right here, would make the left and the right side the same. So if I plug in an x value of 3 here and I do all this math, I should get a value of 0. So I have 0 equals 0. So I'm going to do that down here as a check. So I can look at what is 3 minus 5 quantity squared minus 4. Is that going to give me a 0? If I've done all my work here right and interpreted my graph right, it should. So 3 minus 5 is negative 2. And negative 2 squared would be negative 2 times negative 2, which is positive 4. And then I have 4 minus 4, which is 0. And so yeah, that means 3 is the correct solution. 7, I can look at the same thing, changing this to a 7. And so 7 minus 5 is positive 2. Positive 2 squared is 4 also, and 4 minus 4 again gives me 0. And so I can verify those are solutions, because that's what solutions mean. They create a true statement in an equation. All right, let's take a look at the second example. So for this one, here is our quadratic equation. And so again, I would undo this subtraction, so I'm going to add 2 to both sides. So this creates negative 2 times x plus 3 quantity squared equals 2. So my left side is going to become one of my functions, so I'll call that f of x. And it's going to be a parabola because it's quadratic. And then my right side will become my second function, so g of x, which will be 2, and that again is going to be a constant function, a horizontal line. So I need the vertex for my parabola, which would have a vertex of negative 3, 0, h, k, opposite of the 3 giving me my h coordinate. And so I have negative 3, 0. My a value this time is negative 2, which means I have a stretch by a factor of 2, vertical stretch, and a reflection across my x-axis. So that means that 1, 1 is going to stretch, and then it's going to reflect. And negative 1, 1 is going to stretch by a factor of 2, so its vertical distance is 2, and then reflect. And my 2, 4 is going to stretch to 8, and then it's going to reflect, so now it's down here at negative 8. And my negative 2, 4, which would start here, is also going to stretch and reflect. So it ends up here. So this is my f of x function. And then I'm looking at my g of x function. So my g of x function is the constant of 2, which means that it goes through all the points that have a y coordinate of 2, which is here. So what I notice here is that, in this case, this horizontal line and this parabola, this horizontal line being my function g of x, they're not going to intersect ever, because the end behavior goes down to negative infinity. They have no points of intersection. If the two graphs of the functions have no points of intersection, that means that there are no real number solutions to this equation. So that would be my conclusion. So there are no real number solutions. There are some imaginary solutions that we'll learn how to find with algebra later on. So there are no real number solutions to this equation. Negative 2 times x plus 3 quantity squared minus 2 equals 0. And for now, that's all you need to understand. That's what your graph is telling you, that there are no real number solutions. All right, so that's a couple of examples that demonstrate when we have no real number solutions, or we have, in this case, 2 solutions from those points of intersection, and that's pretty much the 2 possibilities that we'll be dealing with right now. So at this point in time, this would end the lesson, and if there's you can begin your assignment.